All right, so this is our new unit called Fresh and Saltwater Systems, and our first topic is a world of water. So water, as we know, it's the key to life. More species of organisms inhabit water than any other places on Earth, and we know that all organisms, they require water to survive. So here we'll talk a little bit about salt water. Most of the water on Earth is salt water. It's the water such as ocean water and seawater, and they have a high salt content. So about 97% of Earth's water is salt water, and it's unfit for us to drink in that form. We can't drink that salt water. It would just dehydrate us. So fresh water, that's the water we would find in lakes, rivers, ponds, wells, those types of areas, that's called freshwater. And most organisms then can drink that type of water or use for life functions. So just looking at this diagram here, Earth's water supply, 97% of it is salt water. And then about 3% is fresh water, found as ice, and then liquid water. Here, if all the water on Earth were in a glass, again, salt water 97%, fresh water is about 3%. The water in the atmosphere is about 0.0009%. Then if we take that fresh water from here and we look at it here, about 1% is water in lakes, rivers, and wetlands. 22% of it is found as groundwater, and then 77% of it is found as ice. And how do we depend on water? Well, about 65 to 70% of our body mass is water. Compare that to an apple. An apple is about 84% water. Watermelon is about 98% water. The amount of water in our body is not constant. When we exhale, we're releasing some water vapor into the air. Every cellular process, it's going to use up a tiny fraction of our body's water. To maintain homeostasis, a normal body temperature of 37 degrees Celsius, water is given off as sweat. We lose water when we eliminate waste. That water that's lost needs to be replaced. They say about 2.5 liters each day. That's how much water we need about each day. And then what does water do for us? Well, lots of things. We need it for digestion, our membranes. We need it for growth, for our body cells to grow, reproduce, and survive. The water flushes out our body waste. The water lubricates our joints. It's the major component of most of our body parts. The water helps to deliver the oxygen to the entire body. Water converts food to components needed for digestion and survival. It's a shock absorber for our brain and spinal cord, regulates our body temperature. It's needed by our brain to make hormones and neurotransmitters. So we need water for a lot of processes in our body. But water is also vital for the way of life and our quality of life. We need water when we brush our teeth, take showers, wash our dishes, do our laundry, for irrigation, farming, growing fruits and crops. Even when we manufacture jeans, water is used for washing the fabrics and for dyeing. Making soft drinks, water is the main ingredient. It's even part of the cleaning process for the bottles. Then we also see like recreational activities and so on, like swimming and skiing. So the water cycle, it's the water cycle that controls the distribution of Earth's water as it evaporates from the bodies of water, condenses, and then precipitation. And then it will return back to those bodies of water. If there was no water cycle, the current rate of evaporation of water from the oceans or lakes, rivers, and land, it would completely dry out the Earth in about 3,000 years. And keep in mind, it is the sun's energy. It's not shown here, but it's the sun's energy that does drive the water cycle. All right, so make sure you do know the terms. You've probably learned these before as well. Evaporation, change of state from liquid to gas. There's always some water vapor in the atmosphere. Condensation, that's when there's a change of state from gas to liquid. The gaseous water remains in the atmosphere until it cools. Then as it cools, water vapor condenses to form clouds, and then we'll have precipitation. That's when we see the rain and the snow, that liquid or solid water will fall from those clouds. So water is always moving, it's always flowing, evaporating, condensing. However, the overall amount of water on Earth will always be the same. So in fact, the total amount of water on our planet and in our atmosphere has not changed for billions of years. So think of that glass of water that you're drinking today. It may include some of the water particles that cleaned and cooled down a dinosaur's skin millions of years ago, right? And that's all because of the water. It's always cycling. All right, so this distribution of water on Earth, so like we talked about in the beginning, the vast majority of water on Earth, it is 97% as salt water. We cannot drink salt water. Neither can other land-living organisms. We need that fresh water to meet our water needs. And it's barely 3% of the water on Earth that is fresh water. And most of that water is frozen as ice, large masses of ice. And these frozen expanses of water, they form ice sheets at the north and south poles and glaciers in high mountain tops. Compressed sheets of snow and ice, they cover about 10% of Earth's land area, and they're locking up about 3/4 of the planet's fresh water supply in that solid state as ice. So a little more than 0.5% of Earth's water is found as liquid fresh water. And nearly all of that water occurs below the surface as groundwater. This is showing that as a bottle graph, showing that distribution of water on Earth. Water enough for all. This is showing, Brazil, Canada, China, United States, and then other countries, and the amount of fresh water in percent. So it's 4 countries that hold nearly half of Earth's renewable supply of fresh water. All right, so Brazil 18%, Canada 9%, China 9%, United States 8%, and the other countries total is 56%. Water cycle, it ensures that the total quantity of Earth's water stays the same. It has to supply tens of billions of other organisms with the water they need to survive. It includes over 6 billion humans. But keep in mind, it's human activities that are adding a lot of waste and pollutants to Earth's water resources. Okay, when we talk about water quantity, that's the amount of water. When we talk about water quality, that's the characteristics of a water resource that make it suitable or unsuitable for various uses. So water quantity and both water quantity and water quality are both concerns. So managing our water resources, water management, it involves balancing the water needs of people, of industries, of wildlife, and the environment with the ability of freshwater systems to remain plentiful and clean, right? We need our fresh water and we need it to be clean so that we can use it. So to manage water properly, we need to know how much water we have and where it comes from. We also need to know how water is being used and how it can be negatively affected by pollution and overuse. So here we're just looking at this map here showing about 9% of Earth's fresh water is found in Canada. Okay, I'm going to pause here